Thank you. All right, give me 1 second to get set up here. You run so slow. I'm just kidding. There it is. Can I kick it? Okay, anyways. Good morning, everybody. How's everybody doing? That was weak, but it's okay. There he is. First of all, let's give a round of applause for everybody at GrrCon here. Come on. That's awesome. I want to say a special thanks to everybody that makes this possible. Doing conferences like this is no easy task. It takes everything from you personally and professionally to kick off one of those. And so I'm really excited to be here today to kick everything off. And I have some good stuff today. It was funny. I woke up this morning, and one of my demos was to show getting around Windows Defender, and which is not difficult. But they've homed in on me lately as an individual and on the tools that I write because they're. I don't know if you know how like antivirus works today, but they're touting machine learning and behavior and all this other stuff, right? Really, what they have is a bunch of people like looking through VirusTotal to figure out whether or not they can write signatures, and that's the behavior. Like you're using behavior and machine learning, which I guess the machines are the humans, to build the signatures to write the tools. And so lately, I had a tool called Magic Unicorn, which is a tool for PowerShell obfuscation, and I got into a little bit of a tiff back and forth. And by the way, this is a full disclaimer: a lot of great folks over there working. Just dislike them writing on specific tools. And so right the day before Black Hat, I was going to give a big demo in Unicorn, and they pushed a signature update that found a specific pattern in Unicorn for how they were detecting. And I feel like they're like literally waiting for me to give a talk because they know I'm going to talk about it, and then they push a signature update out. And so I woke up this morning to test my demo that I had tried up yesterday, and it was getting blocked again. I'm like, huh, okay. So it took me about 20 minutes or so, and now I got a new version, which I actually found out exactly the pattern. I'll talk a little about that, of what they're flagging on nowadays, and so it's going to take them a lot longer next time around to go around it. But anyways, that was this morning. Worked out good. I'm Dave Kennedy, founder of Trusted Second Binary Defense. I won't go through everything, but the biggest thing for me is focusing on specific attack patterns and understanding how to detect them is kind of my main area of focus. I've written a lot of tools around exploitation, so I wrote the Social Engineer Toolkit, wrote Unicorn, the Pen Testers Framework. I co-authored the book Metasploit, the Penetration Tester's Guide. Helped with the TV show Mr. Robot, which I thought was really cool. Started a conference called DrrCon with a couple of friends, and testified in front of Congress and some other stuff. I own one suit. And so if you look at all of my media interviews, I'm wearing the exact same suit. Every single one. And what's interesting is I didn't realize I was doing this, but I have like probably about 50 ties. So I have one suit, 50 ties, and like 3 or 4 dress shirts. And it sucks when you go to a customer, you have to be on site for like a week, because then you have to like recycle them, but you can mix and match the colors. So you can like go with like a white with like a khaki, and then like a different colored shirt with the same khakis. You can wear khakis like the whole week. You can do one pair of pants. But what I didn't realize is that every interview that I've been on, I have the same tie. And this goes back like 5 years, by the way, when I was heavyset. Same exact tie. And I didn't notice this until I was actually speaking in Chile, and I was on stage, and I had showed a video, and I was wearing the exact same suit and tie that was on the video. And I'm like, that's fine, that can happen. Then I played another video, and I was wearing the same exact suit and tie. And then I played another video, and I was wearing the same exact suit and tie, and everybody in the audience started laughing because they started picking up on it. So I finally realized that even Big Dave wore the same tie. So it's right, branding. Interesting enough, I was in a rap video a Chris Brown rap video at that. I'm not a fan of that specific. Well, whatever, it doesn't make a difference. But when it comes to that rap video, I thought that was kind of interesting because I literally was sitting behind, and there's a bunch of dancers behind me. And I'm not a rap person, I'm like a 90s grunge. And so I started like bopping my head thinking like, hey, I should probably like look like I'm getting the video. And then they stopped the whole thing and like, hey, can you stop bopping your head and just look like you're hacking? And so did that, and that was fun. That's the most awkward, that's probably one of the most awkward things I've ever done in my entire life, to be honest with you. Like it's like a blown out studio and a bunch of people there, and someone taps me on the shoulder and it's Chris Brown. He's like, hey, I heard you're a hacker. I'm like, yeah, I'm a good hacker and all that stuff. He's like, well, what can you do? I'm like, I can hack stuff and things like that. He's like, well, can you hack me? I'm like, sure. And so it's Chris Brown and another guy named Zoe Dollars, two rappers. And nothing against genre of music or anything. I'm like a Offspring, Blink-182 type of person. But so they're sitting there, and I start pulling up some information about him. I pull his like social security number and where he lives and how much money he makes and how much he's got in his bank account, just for like fun example things, right? And he starts freaking out and he starts screaming and he walks away and he won't talk to me for like an hour. And he's like, you can see when you've done like a magic trick and you start like doing stuff. There's like a group of people and they start pointing at you and they're talking about you and you know they're talking stuff about you, but you don't know what they're talking about. And eventually he came back over and was like super cool. He's actually a really nice guy. Both those guys were pretty cool. Anyways, that's not what we're here to talk about today. The main premise of this talk is really talking about where we're at from a security perspective in the industry and what I'm seeing out there, both from an offense and defense perspective. What's interesting about today is that a lot of the focus is really on understanding the techniques of attackers. You look at the MITRE ATT&CK framework, you look at the Atomic Red Team stuff that all the folks at Red Canary are doing. All of those things are awesome stuff that we're focusing on very specific techniques of attackers to try to understand that. And so we've gotten to go into a lot of different types of companies and understanding where they're at, and a lot of sophisticated companies. And what's interesting is that if you look at where we're at today from where we were at 10 years ago, it's really kind of the same. We're still very much focused on signature-based detection. When I talk about signature-based detection, it's morphed a bit. It's a little bit more complex than that. We'll look for very specific strings that attackers would use, like regsvr32 or MSHTA. We'll look for specific PowerShell commands that we're executing, like encoded command or invoke expression. We'll look for very specific patterns that attackers use, but we're still focusing on the very specific types of attacks that we're using out there. And I'll talk a little bit about that in what we're doing. What's interesting is that the attacks change, and they change often. And so if you look at what we can do as attackers, if we modify or manipulate the ways that we go after an organization, that can change drastically from a case-by-case basis based off of whatever organization we're going after. And Windows Defender is a great example. If you look at what you can do, I actually did a funny joke. So when the content settings-ms came out with Matt Nelson, came out the technique, I'll talk a little about that later. I put an Easter egg in one of them, and I uploaded it with the individual's name in there, just to see how long their team would take to actually see that and respond back, and it was like 4 minutes. There's people just sitting on VirusTotal combing through data so they can write signatures very quickly as a main method for detection in their environments. And these are companies that focus on machine learning, artificial intelligence, and behavior analytics, and all of these things that we talk about today as game changers in the industry. And so if you look at that, and what's interesting about that approach is that we talk about the tactics, techniques, and procedures of attackers, the TTPs. That's the big buzzer right now. And there was an individual, Jeff Moss, that right before the keynote at Black Hat this year, he said something that didn't get picked up very well, and I think it's a really important topic. And he said that as an industry in general, as a whole, we focus on the techniques. We focus very heavily on what we know based on a specific data breach or the method that they used, and we use that to try to build detection off of. We don't necessarily at all focus on the tactics or the procedures that they operate by. So our industry right now is still very much focused on the techniques of an attack, not necessarily the patterns of behavior that they exhibit when they go after an organization. We talk about looking at an attack, everything from the reconnaissance phase all the way to exploitation. Hey, once we're on there, what do we do? Do we do privilege escalation, extract credentials? Do we move from one system to the next around lateral movement or post-exploitation scenarios, and post-exploitation to persistence footholds and exfiltration of data? All of those things are patterns of behavior, the tactics that specific attackers use in an environment, not the actual specific techniques. And so what's interesting is what we can learn from a lot of these techniques is great. But if you can't do direct simulations and look at the whole picture around your environment and say, hey, first of all, and I'll reemphasize this later on down the road, if you don't have endpoint logs, you're behind the curve when it comes to your overall organization. I know that costs you $1 million in Splunk licensing, and you can't afford it. But you need to have those specific areas. If you don't have those key areas of visibility, that's important. But if you're not simulating specific attack patterns in your own environment and going after an organization and looking at those patterns and saying, hey, instead of focusing on Mimikatz, I'm going to focus on the technique the tactic that Mimikatz uses. Instead of looking for a very specific debug flag in LSASS, if you're already system, you don't need the debug flag in LSASS to extract clear text passwords out of memory. So looking at the tactic that's used to get those passwords and using those passwords in different locations, that's more about what we're talking about today, and it's something that we don't do very well at right now. And if you look at kind of the current state of detection where we're at, what I thought was really interesting, I did a blog post in 2012, and this is a binary. It was one of the first ones that talks about using Python to convert to a binary. There's py.exe and there's PyInstaller, which can convert a Python script into a binary. So it wraps the Python interpreter into an actual executable. Ends up being like 10 megs for like five lines of Python code, but it works fine. And most antivirus looks for the very short patterns of in that anyway. And what was interesting is I went back to my blog post recently. This was like a couple weeks ago. And what this is it's a Python shell. So it's a reverse shell. So if you execute an executable that is a non-code signed binary from a machine, it connects back through an AES encrypted shell and establishes command and control, right? So public source code. The binary itself didn't change. The hash values were exactly the same from 2012, and it was actively used. I think we had over 172,000 downloads for this specific one, right? And so I uploaded it a couple weeks ago, and 6 out of the 60 detected it, right? Can anybody imagine which one of these were the next generation product lines out there? Any of those? Not a one. Not a one. These are actually the traditional ones. I think McAfee picked it up, Symantec, a lot of the other older ones, AVG actually, and I thought what was really fun was ClamAV. Which I didn't even know that was still around, but that's cool. Hey, it's all good. It's awesome. So if you look at that, and this is a non-trusted, unsigned binary, and granted, VirusTotal isn't a direct representation of sandbox evasion and things that can happen in those environments, but I thought that was really interesting. I released Trevor C2 last year at GrrCon. And what I thought was interesting with that is that it has multiple components, and it's expanded since then. If you're not familiar with Trevor C2, I built it to be to get around evasion techniques or get around detection techniques in companies around evasion. And what it does is it'll clone any website you want to. So you can clone Google, you can clone whatever website you want to. And what happens is it embeds the command and control directly through the HTML source code of the document itself, randomly and through an AES encrypted randomized cipher. And so what will happen is when you're looking at the website, you go to the website, it'll look like a legitimate website, right? There's no actual command and control infrastructure. There's no payload delivery when you're downloading specific files or commands. And the stager uses PowerShell, C#, Python. It's multi-platform. And I released that a year ago here at GrrCon, and we have 0 out of 60 hits, especially when embedded in a document, but even code execution in those individual environments, there's nothing out there. So the current state that we're looking at right now is that if it's not a big enough bubble for them to write specific signatures off of or push down specific indicators, it's not going to be detected in most cases. Another good example is this is a 2-week-old technique when it came out. And if you're not familiar, Matt Nelson, Enigma 0x3, released an extension type that you could use that gives you remote code execution. And it was an extension type that could be used inside of a browser. It was with the settings content or content settings -ms. I'll have it later in the slide. I always get mixed up on the extension name. But what was interesting is it was released 2 weeks at this point in time of this post, and there was 0 out of 60 specifically detecting it in document files. Now Microsoft conversely pushed a patch out so you can't embed it in documents. You can still execute it from websites, and you can still definitely execute it when it comes in. But just another good example of detection. And so what's interesting about these areas is that we're very focused on patterns, right? We're looking for encoded command. We're looking for invoke expression. We're looking for invoke-mimikatz. That was the most interesting one. So if you did invoke-cats, right? It shaved off 17 of the detection criteria out there. And so you look at those interesting patterns and you say, okay, well, can we manipulate things in a different way that change things around a little bit? I'm going to show you an example of that right now. So let's do a demo. Now, it's funny when you're going against a bunch of folks that are writing signatures for your own tool. And again, I'm not advocating that my tool should never be detected, okay? That's not the intent of Unicorn. What I'm trying to explain is that signatures themselves are not the right way to be focusing on what we're dealing with. We should be looking at, hey, why is PowerShell's length 1,000 characters, and why is it injecting shellcode directly into memory? And why is PowerShell now beaconing out to the internet when it hasn't before in the past? Those are all common things that we can look for from a behavior perspective instead of a pattern that allows us to say, hey, we actually have to have people, actual analysts, looking at that and saying, that does not look right. Now, there's some automation you can do in those specific cases, but we have to have people there. Now, it's interesting when you go around a specific antivirus product is that if you make it public, it gets a better signature each and each time. And so my hope is that every time I would continuously release a new one and I tweet about it, the detections would get better. And the truth of the matter is that they're in a very tough spot at Microsoft because you can't just block virtual alloc. You can't just block create remote threads. You can't just block PowerShell. Well, you could, right? But there's a lot of things that we can't do in the context of an enterprise. And so we're left on our enterprise side to say, hey, we need to use constrained language mode. We need to use PowerShell version 5 or version 6. We need to do script block logging. We need to do all these additional things that we can do that aren't out of the box that could hopefully help us protect against a lot of these. And so with Unicorn, I'm going to give you an example here. So and you can get Unicorn. I think my computer just locked up. That's awesome. Oh, no, it's over there. Okay, good. How do I get back over here? Okay, computers are hard. Macs are supposed to work. They're supposed to know what you're doing, and I don't understand why. Let me mirror my desktop here real quick. So with Unicorn, and you can get it from github.com/trustedsec/unicorn. Now, I like using Metasploit because the Metasploit stager itself, there's a million signatures out for it. And that's why I love using Metasploit as an example of something that is commonly used in the environment that's public code that people write signatures off of. And Windows Defender specifically focuses off of a encoder type called swart. And so what swart looks for is if there's static shellcode opcodes that are being used inside of the stager that we can predict patterns off of. So if you see a memory instruction set of like 08C and 0F1 or whatever it ends up being, 0xF1, you see those specific strings commonly used across the board. And so they'll look for those patterns of shellcode and they'll say, okay, and what will happen, by the way, is when you launch PowerShell, the command itself is interpreted and they do a quick signature through Defender. But then what happens is that it gets loaded into what's called AMSI, the anti-malware scan interface. Hopefully you're familiar with that. But the anti-malware scan interface is a DLL that gets loaded into memory that right before it's about to execute in memory, right before it's about to execute, it's really in its rawest form. It's decoded. It's about ready to execute. And then they do a comparison to that to their signatures in their environment. Now, what Microsoft uses is a term called telemetry. And this is a big term to understand because telemetry is basically information that is taken off of your Windows 10 machine that is then sent up to Microsoft to do analysis with. And a lot of these companies are using telemetry. Telemetry is like the big deal right now. Everybody's sifting as much possible data as you possibly can off of an individual system. If you're using EDR products, there's so many different types of telemetries that are taken off of that system and sent back to a massive petabytes of cloud infrastructure that use that for big data analytics and everything else that's going on. Telemetry is used in a sense, and Microsoft does it with Defender. Anytime that something is unusual, like maybe a Windows call or something that could be suspicious, gets sent up to Windows. And it's actually in your settings here. If you look at Windows Defender, and if you go to virus and threat protection, you can see it has real-time protection, but it says cloud deliver protection, and it has automatic sample submission, which is the most important part. So the automatic sample submission will automatically send commands that you execute, scripts that you're using, things that it might deem as possibly weird. It'll send that up to Microsoft so that they have this army of folks going through writing signatures. If you look at any of the folks on Twitter, like, oh, hey, I saw this awesome macro Excel document that was spawning PowerShell that does this and this and this and has all this obfuscation on it. They literally have people going through and looking for weird things. They see, hey, Excel spawned a child process of this. It's probably much. Let's take a look at it and write a signature for it. So that's kind of how the process works. Very manual in nature. They have a process for it, but it's very manual in nature. So this telemetry data is used to then take all this back and then write specific signatures off of it. Now, with Unicorn, what was interesting is that right before Black Hat, it was fine, and it's been fine for years. Like a Unicorn was written, I think, 5 or 6 years ago, and I still have a version of Unicorn that I wrote 4 years ago that I never made public that still gets around all the antivirus components out there too. But this one specifically, right before Black Hat, it started to heat up a bit with Microsoft, and they're focusing on the tool. And what I thought was interesting is that they were focusing very much on the shell code itself. So if I used Metasploit, an interpreter shell code, they would trigger that as malicious. But if I used my own custom shell code, they wouldn't, right? So it's very specific off of Metasploit. So let's go ahead and take a look at the old version of Unicorn. And I'll just spawn an interpreter shell. And I'll just put a bogus address in it. It doesn't make a difference. And what this is going to do, let me blow this up a little bit, is it's going to create an obfuscated PowerShell command that fits in the command line length. Now, what's interesting about the detection evasion on this, blow this up a little bit. Can everybody see that? Now, notice most people will flag on encoded command. Now, do you see -en, -ec, -anything here? No, right? So I use value to string, which reassembles encoded command down the road for us. So if you're looking for encoded command or EC or E-EC-EN-ENCO, etc., you're not going to see encoded command specifically hit in this one. So it is base64 encoded. It's base64. It's cast Unicode then base64 encoded. And then what's interesting is most EDRs focus on -W or -window hidden, window style hidden, right? Do you know you can do /W and that it gets around pretty much every EDR that's out there today? Same thing for -command /C. A good one for a major EDR tool that does application controls, if you put carets in there. Carets, for some reason, get around the evasion techniques as well. So you put a couple carets in there, good stuff as well. Super hard, super technical. A couple of other ones will also do smart sensing on base64 encoded strings. Now, I thought that was interesting because I chunk up the base64 encoded strings here, so they're not actually legit base64 encoded strings unless you actually use the PowerShell programming language to reassemble them. So it splits up and chunks up the base64 encoded strings as well. Let's take a look at what the code's doing real quick. Let me just do some quick on-the-fly Python, which my Python is horrible, which is fine. Everybody's Python is horrible. Actually, that's Perl, sorry. Nano is far superior than VI, so I'm okay with that. All right, all I'm going to do is base64 decode this really quick, okay? And what that's going to do is show me what is actually going to be executed in PowerShell. Now, what's interesting with this one specifically, and why it gets flagged, if you notice at the top, they're all randomized variable names. So we do -jp, which is calling PowerShell. We import kernel32.dll, MSVCRT.dll, and a number of other ones, classes that we use later on for virtual alloc, create real thread, and a bunch of other stuff. But anyways, what's most important here is the shellcode components of it. Now, what was interesting with the latest Windows Defender update is that I noticed that if I started removing, just by basics, some of the shellcode, like chunk it up and start removing, eventually it got around Windows Defender. I'm like, well, maybe they did it based off of length. So then I did a bunch of null bytes, and I ran it through, and it got around, and it still executed. So what I started looking at is I wrote a program, and I'll probably open source it. I open source everything. But what it does is it chunks up every fragment of code and then submits it basically to Defender to see whether or not it gets picked up. And so it basically does analysis automatically to see which portions of the shellcode are getting flagged with AMSI, with PowerShell. And so if you look at here, what was funny is we initially over here, we defined what's called a byte array. And these are the bytes that we're going to use to inject our shellcode directly into memory. Now, what I found is that if I split these up in certain locations, most specifically where Defender is flagging, in this case, they're flagging off of 0x51 and 0xFF. So if I chunk that up, it works fine. And so it got around it, right? So chunking up your shellcode basically was the biggest area here. So it didn't create a lot of space. We're restricted to a lot of command line syntax here, but it allowed us to get around it. Now, what was interesting, and I didn't think about this at the time, but they have a lot of variables to deal with. So they have to say, okay, well, if I'm blocking shellcode, what impact does that have on my enterprise? Like, how am I going to block those specific areas across the board? And one thing I didn't think of is that they were looking for 2 patterns, and I didn't realize this. So if I look at this really quick, and I try to make a unicorn as obfuscated and unique as possible every single time, if you notice here, if I run this, you get an error message in the bottom that says, this script contains malicious content and has been blocked by your antivirus software, okay? And it's interesting working with signatures because you can remove a certain fraction, but it'll still get flagged, or you can remove a certain fraction and it doesn't get flagged. And then you run into weird bugs. Like there's a bug with Windows Defender right now that was really bad about a month and a half ago, but they kind of quasi-fixed it, which was if you got something that was flagged in PowerShell as malicious content, it would then from there on persist. So anything that you ran, if it was like hello world, would be marked malicious. And everything on your system then would be marked malicious. It was really bad, right? And so now it only does it half the time now. So it's gotten a little bit better. So what sucks about that though is because you're sitting there doing testing, you're like, hey, they got flagged as malicious. That got flagged as malicious. And you're only at one last variable name, like 8 = 1. That got flagged as malicious. What the heck is going on here? And you're sitting there for 2 hours trying to figure out what is going on to figure this specific key thing out. And so anyways, if we're getting hit here, and this program that I wrote, actually found this for me this morning. If you look at what they're actually flagging on, and I didn't think about this at the time, which I should have, but I have a hard-coded process name here of Win32. So if name is Win32, and we have any type of bytes now as the new Defender signature, then trigger on a specific antivirus. So if I just change this to Moo, we now have no problem. And that's where we're at today. I heard the sighs, I know. So I wrote a new version this morning of Unicorn. And this is version 3.2.7. And it'll be released later today after I get done with the talk. I was actually going to release it on stage, but I have really bad cell reception. So I couldn't actually do it. But all I needed to do is that. So real hard for me to do. It was real difficult this morning at breakfast. I was actually at breakfast. There was a bunch of folks talking computer stuff over there on the left, and I was literally eating fruit. And I'm sitting there trying to code before I had to walk over here to get here, and I got it done, which is awesome. It's a lot of work. So it's interesting when you look at chunking those up as one capacity, because they were saying, hey, if it's Win32 as a process name and you see specific opcodes being executed, then write it. But what's interesting about this approach is what? This is all public data, right? Source code is open. I release it all the time. I tweet about it. All of this information is out there. What about the stuff that's not published? What about the attackers that are focusing on malware that they change their techniques every single week and they literally wait for it to detonate in customer environments before they write a signature for it? That's where we're at today. And that's a problem. And of course, the bug. I hated that bug. That literally blew 2 or 3 hours of my time. I'm like, why is my print statement flagging on antivirus? So then I started writing an encoder for a print statement, and then realizing eventually that it was just a bug in the software. So we are a signature-driven industry. And what's interesting how these components work, and don't get me wrong, there are some great components that are coming out there, like the machine learning stuff. If you're able to take a large, copious amount of data and do statistical analytics around it, and say, hey, these are common patterns that attackers use for binaries, non-code side, has network connections, never been seen before in the wild. All of those things are cool things that you can say, hey, maybe I can bubble this up to an analyst to be able to see specific things. Or telemetry-wise, we can see behavior on that and say, hey, this is something that we need to bubble up to our analyst because it exhibits these types of behaviors. Hey, it's a specific length size. Hey, it's beaconing out to the internet. These types of things that we can focus on. And so really, a lot of the focus right now is on having these massive teams, hunt teams, going through large amounts of data with VirusTotal, going through copious amounts of data through what they see on Twitter. Twitter's a huge area for that, for collaboration and sharing. And so you look at that and you say, okay, well, they're still focused very much on binaries. And binaries do make up a large percentage. From what we see, it's about 84% of all malware drops still today are still leveraging binaries. Commonly, even documents that have macro injections in them and stuff like that. With macro injection specifically, you'll still see PowerShell and C script and W script and other ones. But in most cases, they're going and dropping a binary and everything else. PowerShell injection is about 13%, and then about 3% are what we call lol bins. Everybody familiar with lol bins? If you're not familiar with lol bins, I'd heavily recommend taking a look because then you're behind the curve again when it comes to detection. Lol bins are legitimate binaries that are shipped with Windows with Microsoft. And these are executables that are on every single Windows platform, everything from Windows Vista, which I don't think anybody here still use Windows Vista? Rocking it? No? Okay. Windows 7, right? Like a lot of Windows 7, I'm sure. A lot of Windows 10, Windows 8, right? Not really? Okay. Good. When it comes to Windows, they have all these different binaries that are in place, and there's a whole list of them. There's a total of 68 right now that have been discovered. 68 total binaries that are code signed by Microsoft, which means that they're legitimate binaries, right? They have the CRC checksums and the digital certificates are good, and it's code signed by Microsoft, and our application whitelisting tools we put in allow that because it's Microsoft, that allow us to then go and do certain things like download code directly from the internet and execute in memory, convert certain things to specific formats, inject DLLs directly into memory. And there's a great reference by a guy named Advar Mo, who's pretty much centralized a lot of the research from Casey and Casey Smith and a lot of other people out there that have done a lot of this great research out there. And they're called LOLBAs, binaries, I forgot the acronym for it, but it's basically living off the land as far as binaries go. And what they are, living off the land binaries, that is what it is. And so what these are is very specific known executables that allow you to directly execute code into memory or do process level injection, whatever you want to do. So some of my favorite ones, and I love this meme, has nothing to do with the slide at all. It's just awesome. And then, and so a couple of these are really good ones, which is like WMIC. WMIC, you can directly download something from the internet and execute it. CertUtil, you can directly download something. CertUtil, like import, export certificates, you can directly download code from the internet and execute, which is fantastic. MSHTA, one of my other favorite ones, which hopefully are looking for that process being used in the environment. But MSHTA, go and download a text file. You can be like, hey, MSHTA, go and download something from github.com/awesome/blah.txt, download it and execute it into memory. It's awesome. RegSVR32, same thing. It's proxy aware, which is even better. All of these different binaries that Windows has available for us to allow us to do execution. There's a million of them. MSBuild, CSE, CBD. All of these have code execution functionalities in them and things that we're probably not looking for in our environments for monitoring and detection capabilities. So when we talk about code execution, thank you, bless you. The PowerShell stuff is all the awesomeness. What's going on here? Is this the Vanilla Ice quarantine?
I apologize.
What's going on?
There's been a sighting of someone with Gerbola.
Gerbola. Okay.
And we're looking for patient 0.
Okay.
If anyone sees them, I have Febreze
and
Lysol.
Sounds good. I showered today. I'm good. I think I'm good. By the way, did you see Vanilla Ice got quarantined in a plane or something that was coming back from international, and there was like 100 people on the plane got sick immediately? So he's all freaking out? Yeah, it's better than Buster Rhymes. So the problem we face is that companies really aren't structured today to handle the advancements. We have a lot of these different pieces of information, like threat intelligence feeds, what we're getting from our EDR products, what we're getting from Twitter and other sources, and we're trying to jam it all into environments, whether it's a hash value that we're getting from a specific feed, and putting that into our environment and hoping that that's what we detect on, instead of focusing on the actual type of tactic that was used in those intervariates. We might have the data, but we don't know what to do with it. Do you know RegSVR32 peeking out to internet is bad, or MSHTA, or CertUtil, or any of those different binaries, or the ones that even haven't been discovered yet that are being used by adversaries? No, probably not, right? And so those are things that we should definitely be focusing, and I'll talk a little bit about that. But the solutions we have are focusing on red, understanding red team tactics. So if I can't detect the initial code execution piece of it, and maybe maybe our detection is built not to handle that, or maybe we do have good detections in place, but we missed it. Can we focus on a lot of the other areas around post-exploitation scenarios to go and find it? And so we talk about leveraging red. I love red teams, and obviously I'm biased. I'm wearing a red shirt. But red teams focus very heavily on understanding the organization that they're targeting. And it's about understanding, hey, if I can build a threat model off of this organization, understand their capabilities, can I get around that and focus on getting access to the types of data that I need? We're supposed to be doing adversary emulation, which is a term used very heavily now in the industry that isn't typically used all the time. And it's building out your capabilities and understanding what you want to go after, and then from there starting to build a threat model that looks at those different areas that you can focus on. And when you look at what red teams can do, and and how they're structured, research is number one. For us, there are companies that have gotten really good over the past few years. We actually have to spend 3 or 4 or 5 months developing new techniques to get access to their environment. Like we have one customer that focuses very heavily off of Markov chaining. So they're parent-child processes, and you deviate from a normal Markov chain, then you get detected, right? And so you have to focus inside the normal constructs of Excel, for example, or Outlook, or whatever you're trying to do to get access. So you have to stay within those specific processes and can't deviate from those. So research is big, and using that as a method for attack, but understanding the environment that you're going into. And as a red team perspective, it's not just going in and breaking into things, it's understanding every single phase of the attack and building it into what the blue team is doing. So if I can't detect the actual exploitation avenue, or they're using a CertUtil or RegSVR32 or other methods, can we look at other methods for detection across their environment? And I think that's what's important here. And so if you look at most organizations that focus on red teams, the red team output becomes the direct input into all the defensive capabilities. It's what we call purple teaming. Everybody familiar with that concept? It's a pretty good term. I think the first person I ever heard use that word before was a guy named Mick Douglas, SANS instructor, a bunch of other ones. And I think Mick coined the term probably about 8 or 9 years ago at a conference called Nauticon. And it made sense because you have more of a collaborative approach where the red is working with the blue together to be able to identify what is happening out there and to really teach the patterns of behavior that are abnormal. And it's a tough one because, full disclosure, running an MSSP, you have to train your analysts to say, hey, if you see this, you still have to be able to figure out what is malicious and what is not malicious, right? Hey, if you see an HTA, that's probably going to always be malicious, right? In almost every aspect, unless you're like Qualys and using an extension, or Amazon has an HTA extension as well. So can you teach those types of abilities to say, hey, this is the type of malicious content we're looking at, and go through a simulation and be able to figure it out? And all of these different things that we do in security, a lot of the technical pieces, all have its way of making your program better. If you look at vulnerability management, still need that, right? We still need to reduce a large percentage of the exposures that we see out there. Penetration testing, I think every year we hear penetration testing's dead, and every year it's not dead. In fact, it's completely valuable for every organization that uses it. But it's changing, right? Instead of just going in and smashing and grabbing everything, we use it for a lot of other things than just, hey, here's a weakness, here's how you fix it. Here's a weakness, here's how you fix it. It's changed over the time. And then purple teaming, which is probably my favorite thing to do in life, is collaborating with organizations or people in general, in teams. If you have a red team and you have a blue team, they usually work really well together. You've ever been to an organization where the security team's like hated by everybody, right? And they're like the draconian firewall folks, and you have to go to a meeting, and it's like you have to do 17 meetings about doing a vulnerability scan because you knocked over that production mainframe one time, and everybody hates you for it, and all this other stuff that happens. What's interesting with red teaming is that, and same thing, red teams, we used to use it as a method or a wedge to get our way, right? We'd go in and say, hey, this is all the stuff that you're doing wrong, and good luck, right? And we'd walk out and be all happy because we just destroyed everything and showed how much our organization sucks. And so that created a lot of hostility and adversary capabilities within a lot of different environments. With purple teaming, it's a completely different approach. It's like, hey, we're going to do X. Can you see Y? And if not, let's figure out ways to get better. And it's working back and forth collaboratively together as a team to figure things out. And the mindset completely changes. Hey, these folks aren't here to point out all the things that we're doing wrong. They're here to make us better. And oh, I can use them now as kind of a subject matter expert. And it changes a lot of the shifting that we see out there. There is a lot of talk around automation testing. If you look at like MITRE, Caldera, the Atomic Red Team, all great resources to be able to test very specific techniques that have been public out there, right? But again, if I throw a couple carrots in those commands, is your EDR going to see that? Probably not. Is your watch list going to see that? Probably not. So obfuscation becomes a critical, important role. So when you're building these out, understanding that if you're using something like automation testing, there's still signatures. There's still ways for us to evade those and change those in a way. And if an attacker is using an exact copy and paste from Casey Smith, Subt's Twitter stream, then that attacker deserves to be caught, right? If you change a couple bytes or change a couple things here or there, and we get around it, good. We can test that and look at the behavior instead of in some way, shape, or form and say, hey, that's not legitimate or normal. So they're good resources and they're things that you can definitely integrate, but I'd still say it's very ad hoc in where we go into and say, hey, we built all the stuff off of MITRE. MITRE's a great resource for information, by the way. Fantastic. The Atomic Red stuff is unbelievably amazing. All great stuff that you can use for reference points that at least test out some of the techniques. But again, if you're not focusing on the tactics of an attacker, we're hurting. If you're in an environment that doesn't dedicate time for research, then I'd heavily recommend focusing on that. Research probably takes up about 60% of my time. And the reason for that is that we go into organizations that have all of these different tools, these endpoint protection products, and we have to figure out ways to get around them, right? We have to be able to do it. So we have to research those methods. Or a new technique comes out and we have to weaponize it very quickly. Enough research to be able to say, hey, we need to go and do that very quickly and do those. Research has to be a major focus of your organization, or else you're going to get left behind. And what's interesting for red teams is that you got to continuously build out your tradecraft. If you're using Metasploit, well, hey, what happens if Metasploit no longer works anymore for you? Or if you're using Cobalt Strike, what happens if Cobalt Strike is no longer working for you? Or hey, you have your own command and control infrastructure that you built from scratch that does all these crazy different methods for exploitation, uses undocumented features for code execution. Like I almost revealed one, unfortunately, or by accident. Good thing I stopped talking. Justin would have killed me on the research team. Methods that aren't getting discovered that are out there, right? Maybe we have to change our tradecraft a bit to go through and do different teams. And red teams are longer in nature. And that example I used before, this was the settings content-ms from Matt Nelson. This is a great example. Is that this was released, and within 14 hours, we saw exploitation occurring in the wild, right? First of all, can any company here that works for an organization make a sweeping change to block an extension type or a type of attack within 14 hours? Like completely block it across your entire environment. Perimeter firewalls, maybe run a registry change across your entire environment, make a patch within 14 hours? Probably not, right? But can we detect those specific types of attacks quickly? And so, as a researcher, hey, it came out, and within a day, I weaponized it so that it could do code execution for our environment to be able to go and actively do. So it really is about understanding research and the capabilities out there as attackers. And so one more time, detection for us has to be number one. Your preventative strategies that you're using out there, like whether it's antivirus or endpoint protection products, are very trivial for most of us as attackers. Those are things that we don't have a tough time getting around to be able to do. So can I detect other portions of the phases of an attack to get better at what's happening out there? And Casey actually did a perfect tweet. It was yesterday. It was like 13 hours ago. And from a defensive perspective, can you perform all of these steps in your environment? And most likely not, right? Can you grab a specific DNS query that was run? From there, can you see what host it was trying to resolve? What processes were on that host that were executing that specific query? And then what tooling or visibility you need to answer that question? So a really good question there is especially for application control bypass techniques, can you see a parent-child process and saying, okay, well, it was executing these specific types of commands in an environment that was connecting out to a specific IP address? That's the stuff we need to know nowadays. And one last takeaway before I close up is you need endpoint logs. Sorry, you really, really do. You have to have endpoint logs at this point. If you're not getting endpoint logs, you're not getting the visibility that you need. There's a great free tool out there called Sysmon. I'm a huge fan of it. It exposes what's called ETW, event log tracing, and you can do exactly what we're talking about here. It's a Microsoft service that gets installed. It's like a 4 meg service, and there's a configuration file that you deploy with it, and you can have it centrally located or push it through group policy. And that exposes a new event log, an event viewer that you can do Windows event forwarding to send it to your endpoints and do a lot of your correlation or detection off of. And those are things that you can definitely use in your environment. And if you can't pay the licensing fee for Splunk, then use something like Elk. Use Elasticsearch as a method for being able to ingest a large amounts of data. You still have to pay for the storage space and everything else. But those are things that can definitely help you out in your environment when it comes to detection. So closing up, I hopefully showed you some cool stuff, how easy it was to get around a lot of the things that are out there. And Windows Defender is just an example, right? I'm not knocking the folks over there doing some great work and research out there. I just don't like when they target specific tools that are open source because they're missing like everything else out there completely. And that's the fact. If we write something custom, it doesn't get detected for years. Like the Unicorn version that I wrote for a firm was 3.5 or 4 years ago. I haven't touched that code in 3.5 and 4 years, and I don't have any problems getting around endpoint protection products. I don't have any problems getting around any of the antivirus tools out there. Again, they're not focusing on the right aspects around what we're doing. Thank you very much. And again, special thanks to GrrCon for having me out here. Hopefully you had a good time. Thanks.